Hello. Today we are identifying and representing functions. So it's a relationship between an action and a result. Carlos needs to buy some new pencils from the school supply store at his school. He asks his classmates how much pencils cost. Angela says she bought 2 pencils for 50 cents. Paige bought 3 pencils for 75 cents. And Spencer bought 4 pencils for $1. So Carlos thinks about the rule for the price of the pencil as a machine. When he puts the number of pencils he wants to buy into the machine applies a rule and tells him the total cost of the number of pencils. There's a way that we can figure out what the rule is. One is to take the information that we have and see if we can find our rate of change. So Angela said she bought 2 pencils for 50 cents. So 2 pencils for 50 cents. Paige bought 3 pencils for 75 cents. So here's 3, and that was 75 cents. And then Spencer bought 4 for $1. So 4 was at $1. Now I can see if there is a constant change or a variable rate of change by finding my constant. So I'm going to take my 50 cents and divide it by 2. And that gives me 25 cents. And if I take my 75 cents and divide it by 3, I get 25 cents. And if I take my 100 cents, which is $1, and I divide it by 4, I get 25 cents. So my rule is each pencil is going to cost me 25 cents. So it's going to be times 25 cents. So if I were to buy 12 pencils, I would take my 12 times my 25 cents, and that's going to give me 300 or $3. Okay? So what we've done is we have our input, which is our number of pencils, and our rule, which is to multiply it by 25 cents. And our output is the cost of the pencils. So you kind of think of it as a machine, a mathematical machine. Ways to identify functions from mapping diagrams. A function assigns exactly one output to each input, and that is important. Exactly one output to each input. The value that's put into the function is the input, and the result is the output. A mapping diagram can be used to represent a relationship between input values and output values. A mapping diagram represents a function of each input that is paired with only one output value. So this is an example of a mapping diagram, and we have our input information here and our output information here. And the important thing to pay attention here is to see how many arrows come off of each input. And as long as it's only one coming off each time, even if it doesn't make sense why they crisscross here, this is the part that's important. It's only one coming off of each input number. And so that means that this is a function. When I look at the one below it for B, and I look at my input, this is my input, and this is my output, I see that 0 has 1, but 2 has 2 lines leading off of it. There's 2 different outputs that work with the number 2. Because of this, this is not a function. Is it possible to have more than one input value, but only one output value? So it's possible for a function to have more than one input value, but only one output. That would be if I had 1, 2, 3, and I only had one number. Is this possible? Yes, it is possible, and it is still a function. In cases like this, remember your input is your x values, your output are your y values. So what this is saying is that y equals 5. No matter what x is, y is always going to be 5. Okay? So we need to look at these two and determine if it's a function or not and explain. So when I look at 4, I have 1, 1, 1, 1. Is this a function? Yes, it is a function. How do we know? Each input has exactly one output. So each input has exactly, oops, forgot the L. One output. Okay? If I take a look at this one, I see multiple lines coming off of my input. So is this a function or not? If you said not a function, you are correct. The reason is it has more than one output per input. It has more than one output per input. We can also look at tables to determine if there's a function or not. Relationships between input values and output values can be represented using tables. The values in the first column are the input values. Those are your x values. And the values in the second column are your output values or your y values. Okay. The relationship represents a function if each input value is paired with only one output value. Honestly, what you're doing is look to see if there's an input that repeats. We have 5, 10, 15, 20, 20, no repeat, so this is a function. So no repeat of input values. On B, when we look at this one, I have 1, 5, 4, 1, 7. I have 1 more than once. So this is not a function. And if we were to explain it, the input values are not only paired, well, no. How do I want it? I think I'll just keep it the way they have it. It's probably the best. It says it's paired with more than one output value. So that would be like saying that 1 is going to 10 and to 4. And so you can kind of see it that way. Okay. Let's look at the number 7 and determine if it is a function or not, and then we're going to explain. So when I look at my input values, I have 53, 24, 32, 17, 45. Is this a function? So yes, it is a function. Each input has exactly one output. Okay. When I look at number 8, I have 14, 8, 27, 36, 8. Is this a function or not? see that I have 8 twice in my input column, so that is not a function. So the input value of 8 has more than one output. We can also look at graphs. The thing I like about graphs is we can use something that's called a vertical line test. It represents a function if each input value is paired with only one output value. And the nice thing about a graph is if you're doing a vertical line test, each vertical line that you do should only have one point on it. Okay? So the graph shows a relationship between the number of hours students spend studying for an exam and the exam grades. Is the relationship represented by a graph of a function? The input values are the number of hours spent studying each student. The output values are the exam grades. And the points are represented in the following ordered pairs. And so what they did is they 1 hour studied was 70%, 2 hours studied 70%, and so forth. And there's 2 ways that we can do this. We can just look at the graph and do the vertical line. And I notice that this line has 2, and this line also has 2. Because there's 2 points on my vertical line as I come down through it, it's telling me that this is not a function. If I don't have a graph, I can still take and look at my x values, and I notice that I have a 2 here and a 2 here, and then I have a 9 here and a 9 here. And because I have a repeat of my x values, I can tell you with this as well, this is not a function because I have a repeat of my x values. Let's take a look at our Your Turn number 10. It says the graph shows a relationship between the heights and weights of members of a basketball team. Is the relationship represented by the graph a function? So if I were to do the vertical line test, is this a function? And if you said no, you were correct because there are 2 on this line and 2 on this line. So because of these 2, it is not a function. Not a function. One way to explain it is during the vertical line test, it shows the input values 70 and 71 have more than one output each. Okay? So this one's coming up with our rule. When I take a look at my input values and my output values, I take my 40, divide it by my 2, and I get 20. I take my output, divide it by my input, so 100 divided by 5 gives me 20. And then my output divided by my input is 20. So my rule is going to be times 20. So that's going to be 20x. And if I take 10 times 20, I'm going to get 200. Okay? And you can finish the others on your own. If you have any questions, make sure you talk to your teacher.